Welcome to India's largest online platform, Unacademy.
Unacademy. Let's crack it. गेट की तैयारी कहाँ से शुरू करें यही सोचते होंगे
Myself, G. Venkata. I have total 16 plus years of teaching experience. So far, I mentored 60,000 plus students for GATE examination. At present, I am doing my PhD. I am doing my PhD in JNTU, Kakinada, in VLSA domain. First, we check it. How to get this Unacademy learning app in our device. Just go to Play Store, type Unacademy learning app and click on install button. Once you click on this install button, you get the Unacademy learning app in your device. Okay, after opening this app, you get the India's top educators in different departments, in different subjects, like this. Here are the few of the top educators. Here are few more. Okay, and one more, the important thing for electrical, ECE, chemical, mechanical and civil engineering students is here recently Unacademy started new batches for GATE 2022 and GATE 2023 students. Okay, now this is the Warvi batch for GATE 23 for triple students. Okay, it was already started. It was started from 18th of January. To subscribe this one, just use my code VRAW10. Next one is Spark batch for GATE 2022 for ECE students. Okay, to subscribe this, use my code VRAW10. Similar Spark batch for electrical people also. Now this is Warvi batch for ECE students, GATE 2023. It was also started from 18th of January. Okay, to subscribe this, use my code VRAW10. These are the top educators handling these subjects in this. So next, Spark batch again, GATE 2022 people. Okay, this is for electrical students. To subscribe this, use my code VRAW10. These are the top educators handling these subjects in this. Few of the top educators. And for civil engineering students, there is a evolve batch for GATE 2022. This is for civil engineering, and it is going to start from 25th of January, means from day after tomorrow. So to get the 10% discount, use my code VRAW10. So this is for civil engineering students. Okay, for GATE 2023, this is the SN batch. Okay, it is also going to start from 25th of January. Next, again evolve batch. This is for chemical engineering students. Very few centers only you get the chemical engineering GATE classes. Okay, so I think so this is the great opportunity to chemical engineering students, because few of my students friends, okay, done their engineering in university and chemical engineering. Okay, because of the lack of coaching, okay, they did not get the good score in GATE examination. Okay, but here you are very grateful to Unacademy because they are providing chemical engineering also. So this is the excellent batch for GATE engineering for chemical engineering students. This batch also going to start from 25th of January. So to subscribe this, use my code VRAW 10. Okay, next, again this is for mechanical students for GATE 2022. It is again evolve batch. It is also going to start from 25th of January. Next one is, this is a ascent batch for again mechanical students for GATE 23. So it is going to start from 25th of January. So use my code VRAW10 during subscription, you get 10% discount. Okay, now once again we check it, what are the different disciplines provided by Unacademy in GATE and engineering services. Okay, GATE and engineering services. See, mechanical engineering, electrical engineering, electronics and communication engineering, electronics and communication, computer science and IT department, civil engineering. Next, instrumentation engineering, production and industrial, and chemical engineering. These are the different courses provided by Unacademy in GATE and engineering service for examinations. Next one is, here you have two subscriptions. For GATE and engineering service, here you have two types of subscriptions: plus subscription and iconic subscription. In both the subscriptions, you are going to be get the classes of India's best educators, and there is a interactive live classes and structured courses and PDFs. This is important. You get the PDFs for every subject, and the most important thing here is you are going to getting the live tests as well as quiz examinations. After completion of these live tests and quiz examinations, they will analyze your answer sheet and they prepare a personal study planner for you. Okay, that planner they prepare based on the way how you answer the questions. Okay, from that they will identify where you are strong and where you are weak. They will identify that. Based on that, they will prepare that notes. Okay, prepare that notes. Okay, if you follow this planner properly, definitely you will get success in your examinations. Now we check the charges, what they are charging for plus plan and iconic plan. For plus plan, these are the charges. There are different subscriptions: 1 month subscription, 3 month subscription, 6 months, 12 months, 18 months, and 24 month subscriptions. These are the charges for that. And at the same time, here the beauty is they are providing the EMI option also. Okay, this is the EMI option, and by using my subscription code during subscription VRAW10, you get 10% discount. For example, if you take 12 months course, it is a regular cost is 30,250 rupees. By using my code of VRAW10, you get this one for 27,225 rupees. 27,225 rupees. Okay. Next one is iconic plan. In iconic plan, you have only two subscriptions: 12 month subscription and 24 month subscription. Okay, in 12 month subscription cost is 50,250 rupees, and for that, by taking 10% discount after using my code during subscription, you get 45,225 rupees. That one. Okay, this is about different subscriptions available and the cost for each and every subscription. Okay, now I am going to intrinsic carrier concentration. Okay, how to calculate intrinsic carrier concentration. Now here Already we know that n value and p value, electron concentration and hole concentration, we know that. Electron concentration in a semiconductor, any semiconductor you can take, that is Nc into e power minus of Ec minus Ef by kT, and hole concentration P equals to Nv into e power minus of Ef minus Ev by kT. So let us, I am taking this is the equation 1 and equation 2. Okay. So we are going to calculating the intrinsic carrier concentration. And we know one thing, in an intrinsic semiconductor, electron concentration equals to hole concentration equals to Ni, intrinsic carrier concentration. And at the same time, we know mass action law. What is mass action law? N into P equals to Ni square. That is the mass action law. That is the mass action law. N into P equals to Ni square is the mass action law. Okay, so the statement for mass action law is, at a constant temperature in any semiconductor, the product of concentration of electrons and holes is equal to the square of the intrinsic carrier concentration, is equal to the square of the intrinsic carrier concentration. Okay, this is mass action law. Now, so you are saying N into P equals to Ni square. So I know the values of N and P. This is my N value and P value. Okay, just I am taking these two and substituting in this equation. Okay, now after substitution, now I am going to simplifying this. So your mass action law is N into P equals to Ni square. Now I am writing that Ni square is just substituting the N value and P value. We know the value of N. N is equals to Nc into density of states in conduction band into e power minus of Ef minus Ec, sorry, it is N type, so it is Ec minus Ef. So it is Ec minus Ef by kT, and P value is Nv into e power minus of Ef minus Ev by kT. So these are the values, Nc into e power minus of Ec minus Ef by kT, and P is Nv into e power minus of Ef minus Ev by kT. Just I substituted the values. Now I am going to doing simplification. So now Ni square is multiplying Nc and Nv, just Nc into Nv into, it is e power minus Ec, next minus into minus plus Ef, next into e power minus Ef, and minus into minus plus Ev by kT, by kT. Here this plus Ef and minus Vf gets cancelled. Now it became Nc into Nv into e power minus Ec plus Ev by kT, and we know that we know From energy band diagram of a semiconductor, this is EC we are writing, and it is EV, it is conduction band, and it is valency band. And here EC minus EV we have, that EC minus EV is nothing but a energy gap, which is EC minus EV. Now I am going to using this EC minus EV equals to EG in this. So I am going to writing this one inconvenient to this. Now Ni square equals to Nc into Nv into e power minus of EC minus EV by kT, by kT. EC minus EV by kT. Now it is Ni square equals to Nc into Nv into e power minus of EC minus EV is nothing but a energy gap Eg, energy gap Eg by kT. So this is one of the equation for Ni, one of the equation for Ni. Okay, now next I am going to simplifying the same equation. So for we got this Nc into Nv into e power minus of Eg by kT, we got this equation, and we know the values of Nc and Nv. Just I am going to substituting the values of Nc and Nv in this equation. See this is our previous equation. We get Ni square equals to Nc into Nv into e power minus Eg by kT. That is the equation. And we know the values of Nc and Nv. So we are writing Nc is 2 into 2 pi into Mn star, effective mass of the electron, into kT by h square whole power 3 by 2. Similarly, Nv value is 2 into 2 pi into Mp star, instead of Mn star it is Mp star, into kT by h square whole power 3 by 2. We know these two values. Now I am taking these two values, substituting here. Now Ni square became Nc 2 into 2 pi into Mn star kT. K is Boltzmann constant, sir, we know that, by h square whole power 3 by 2 into Nv. So Nv value is 2 into 2 pi into Mp star kT by h square whole power 3 by 2 into e power minus Eg by kT. If you observe this equation once, so many number of constants are available. Constant, this is constant, it is constant, Okay, it is constant. It is temperature is variable, not constant. Temperature is varying, sir. Constant, 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 constant. And for a given material, Mn star and Mp star also a constant. For a silicon or germanium, Mn star and Mp star also a constants. Now the variables are, these are the variables. Here T is a variable. Again here T is a variable. Here also these two are also variables. Now whatever the constants here we have in our expression, I am representing, let total constant is total constant term equals to, I am going to representing that by a letter A. Now Ni square equals to total constant term A into here T power 3 by 2. Next again here also T power 3 by 2 into e power minus Eg by kT. Now T power 3 by 2 into T power 3 by 2 T cube. So constant A into T cube into e power minus Eg by kT. That is the value of Ni square. This is the another expression for Ni or Ni square. Okay, here so that is Ni square. Now I am taking the Ni value from this. I am writing Ni value from this. Now we can write Ni is Ni equals to, taking root to this side, square this side. Now it became square root of A into T power 3 by 2 into e power minus Eg by 2 kT. Okay. Now square root of A is nothing but a square root of constant is again a constant. Therefore Ni value is another expression. Some let constant A naught into T power 3 by 2 into e power minus Eg by 2 kT. Okay. So this is the final expression for Ni. Okay, and my sincere request to students is, from this don't write this one, Ni directly proportional to T power 3 by 2. Don't write this equation. This is wrong, because it is directly proportional to e power minus Eg by 2 kT. Also here also we have temperature. Here also we have temperature. Because of that, don't write like this. Okay, if you are writing like this, immediately if they ask the problem, we know the Ni value of silicon at 300 Kelvin is 1.5 into 10 power 10 per centimeter cube. Okay, if they ask at 400 Kelvin, now immediately you are going to Ni1 by Ni2 equals to 300 by 400 whole power 3 by 2. So that is not the correct process. You need to consider this temperature also. Okay, you need to consider that temperature also. Now, so finally this is the equation for Ni. So Ni value of temperature is, Ni value of a semiconductor is depends on temperature. If temperature is changing, Ni value is changing. Okay, so this is the equation for Ni. Okay, now I'm going to next one. Let us, they given a problem to you. The intrinsic carrier concentration the intrinsic carrier concentration of silicon at 200 Kelvin in Kelvin is how much? So at 200 Kelvin, what is the Ni value of a semiconductor, silicon semiconductor? They given the data at 300 Kelvin, Nc value they given, Nv value they given, and energy gap also they given, and Ni value also they given. Ni value at 300 Kelvin they given. Okay, from this you need to calculate 200 Kelvin. First at 200 Kelvin. Now first I am going to writing the equation for Ni. So the equation for Ni value is, or Ni square is Nc into Nv, because they given directly Nc and Nv values, into e power minus energy gap by kT. This is the expression. If you observe, in this Nc and Nv we have temperatures. Okay, we have temperatures in these two. And final expression we derived here is Ni is some constant A0 into T power 3 by 2. Sorry, okay, T power 3 by 2 into E power minus Eg by 2 kT. This is the expression. Okay, now the meaning of given Nc and Nv is, see this, they given Nc and Nv at a temperature of 300 Kelvin. Clearly they are specifying. Now my equation for Nc is 2 into 2 pi into Mn star into kT by h square whole power 3 by 2. This is the equation. Okay. To know the Ni value at 200 Kelvin, first you should know the Nc value at 200 Kelvin. So you need to substitute T equals to 200 here. And you need to know the value of K. We know K, Mn star, we don't know, they did not give any Mn star. Okay, Planck's constant, we know it. Okay, but I know one thing. If T equals to 300 Kelvin, then I know it became Nc value can be written as 2.8 into 10 power 19 per centimeter cube. Okay, that's what I am going to doing here. Now Nc equals to 2 into 2 pi into Mn star into kT. So instead of T, I am going to writing 300 into 300 by h square whole power 3 by 2 into, here I have 3 by t power 3 by 2. Now I am going to writing that t power 3 by 2 by, to compensate this, additionally 300 whole power 3 by 2 you are adding. Now I am going to taking that 300 whole power 3 by 2. Okay, now I am simplifying this. This is nothing but a value of Nc at 300 Kelvin. So you can write now Nc equals to Nc at 300 Kelvin. So Nc at 300 Kelvin, they given the value in our problem 2.8 into 10 power 19. So 2.8 into 10 power 19 per centimeter cube into T by 300 whole power 3 by 2 into T by 300 whole power 3 by 2. That's it. This is the value of Nc we need at a temperature of T. Now you can take T equals to 200 here. Okay. Okay. Now similarly, so okay, now it is 2.8 into 10 power 19 into T by 300 whole power 3 by 2. Just simplify. Next, now I want Nc at 200 Kelvin equals to, just substitute T value 200 here, that's enough. Now it is 2.8 into 10 power 19 into T is 200 by 300 whole power 3 by 2. So from this you get the value of Nc at 200 Kelvin. Similarly, I am going to writing the equation for Nv at 300 at 200. So our Nv similarly Nc is over. Now Nv at, okay, first I am writing Nv, can be written as at 300 Kelvin whatever the value of Nv we have, that value, so that value is they given it as 1.04 into 10 power 19. So 1.04 into 10 power 19 into T power 300 whole power 3 by 2. This is the value of Nv. Okay, now Nv at 200 Kelvin equals to, so 1.04 into 10 power 19 into T by, so I am substituting T value, T given 200, so 200 by 300 whole power 3 by 2. So far we know the values of Nc and Nv at 200 Kelvin. Okay, now I am going to energy gap. There we have kT. So our equation is e power minus Eg by kT. So Eg they given, now I am taking kT. So kT value is, I am writing that kT is k into 300 into T by 300. So any loss, so 300 gets cancelled, you get the T. Now T in k into 300 Kelvin is 26 milli electron volts. That means it is 0.026 into T by 300. So now kT at 200 Kelvin equals to 0.026 into 200 by 300. So far we know the values of all constants Nc, Nv and kT, and they give an energy gap. Okay, now I am taking all the values, substituting in that equation. See, now our Ni value is, or Ni square is Nc into Nv into e power minus Eg by kT. Now I am substituting these values. Therefore, Ni square is Nc value. So they given Nc value as, we got Nc value is 2.8 into 10 power 19. 2.8 into 10 power 19 into 200 by 300 whole power 3 by 2. So this is NC at 200 Kelvin. Similarly, NV at 200 Kelvin. That is 1.04 into 10 power 19. 1.04 into 10 power 19 into 200 by 300 whole power 3 by 2 into energy gap. So exponential term e power minus energy gap, they given 1.12 electron volts by kT at 200 Kelvin, that is 0.026 into 200 by 300. See this. Now in this expression, all values you know. So this is value, some constant, this is some constant you get, this is also some constant you get. Okay, finally take just Ni value is square root of the value what you get. Now you get Ni value. Okay, sir, this is the procedure to calculate the Ni value at a different temperature. Okay, please don't write Ni square directly proportional to T power 3. Okay, don't write this. Okay, don't do like this. This is a wrong method, because their exponential term depends on temperature also. That's why you need to follow this procedure. Okay, next problem. See this, this one also the same problem. This is also same, but they given the temperature is at 400 Kelvin they want. Now here I am writing direct equation. Now Ni square at 400 Kelvin equals to, sir, based on the knowledge of previous problem I am writing direct values. So you can write it as a Nc at 300 Kelvin into sorry, just a minute, I will do one thing. So Ni value, Ni square at T, Ni value, Ni square at temperature T equals to Nc at 300 Kelvin into that T by, okay, here T power 3 by 2, another one T power 3 by 2 is there. So I will mix both. Next one is Nc at 300 Kelvin into Nv at 300 Kelvin into T by 300 whole power 3 whole cube. So here power 3 by 2, power 3 by 2. So total it became T power 3 into E power minus energy gap by 0.026 into T by 300. So you can use this one as a formula. Okay, now I am substituting the values. Now, so Ni square at 400 Kelvin equals to Nc at 300 Kelvin. They given it as 2.8 into 10 power 19 into NV at 300 Kelvin. So that is 1.04 into 10 power 19 into T power. T is 400 by 300 whole power 3 into E power minus energy gap, they given it as 1.12 electron volts by, this is 0.026 into T value is 400 by 300. Just simplify this, you get the value of Ni at 400 Kelvin. This is, don't forget, this is Ni square we are calculating. After this, you need to take the square root of this value. Okay, square root of that value. Okay, this is the procedure to calculate the Ni value at a different temperature. Okay, please follow this. And in some textbooks, they given directly, they related with Ni and temperature. They omitted the exponential term. So don't do that. This is the correct procedure to calculate the Ni at different temperature. Okay, next. So here another problem. So this two semiconductor materials have exactly the same properties. Exactly have same properties, except that the material A has band gap of 1 electron volt and a material B has a band gap of 1.2 electron volts. The ratio of intrinsic concentration of material A to that of material B for T equals to 300 Kelvin will be. So first I am writing the equation for Ni, sir. I am writing Ni. Okay, so Ni square we are writing it as Nc into Nv. Directly I am writing Ni, that's why it is a square root, into e power minus Eg by Kt. Here square we are taking this side, that's why it became a root, 2 Kt. This is the expression. What they are saying, they are taking the two materials. Now let us Ni of A material is, let us Nia, and another material we have Ni B material. They given for these two materials, except energy gap, remaining all are equal. See, exactly same properties. Okay, except energy gap, remaining all are equal. Okay, so now I am writing this one is square root of Nc into Nv Nc into Nv into e power minus energy gap of A material, they given it as 1 by 2 into Kt. I am taking as usual. Finally I substitute the value. Okay, And similarly here for B it is a square root of Nc into Nv, because no change in this, into e power minus of energy gap for second material is 1.2 electron volts. So 1.2 electron volts by 2 kT. Now they want the ratio of intrinsic concentration of material A to that of material B for T equals to 300 Kelvin will be. So that means they want the ratio of these two. So once taking the ratio, these two constants gets cancelled. Okay, these two constants gets cancelled, this one and this one. Now this is e power A by e power B, now e power A minus B. Therefore you can write simply it is Ni of A material by Ni of B material is equals to e power minus 1 by 2 kT by e power minus 1.2 by 2 kT. By simplification, you get the ratio of Ni of A by Ni of B. Okay, so like this you have to solve the problems on this Ni. Okay, so far we calculated the Ni of intrinsic semiconductor carrier concentration. Now with respect to intrinsic semiconductor, if you take, this is the energy band diagram we drawn. We said it as EC, it is EV, and at center approximately at center EFI we have. Sir, in problems you can take this one is approximately midpoint of the energy gap. You can take EFI is exactly midpoint in problems. Okay, so you won't get much difference, you get very small difference by taking EFI at midpoint of that. Okay, now so for intrinsic semiconductor only two parameters we have. One is Ni value, other one is intrinsic Fermi energy level, EFI. Just before we completed the calculation of Ni as well as some problems on Ni. Okay, now I am going to calculating the EFI. So first of all, EFI is the intrinsic Fermi energy level, we called it. Sometimes they mention this one as EI. EI means Fermi energy level of intrinsic semiconductor. Fermi energy level of intrinsic semiconductor. Okay, so you are saying it as intrinsic semiconductor. Okay, you are saying it as intrinsic semiconductor. From intrinsic semiconductor we know only one thing, that is N equals to P equals to Ni. N equals to P equals to Ni, and EF became EFI. Fermi energy level of a semiconductor I am taking it as EFI, intrinsic Fermi energy level. Why? Because you are saying it is the intrinsic semiconductor. Okay, now already we have the equations for N and P. Okay, so these are the equations for N and P. So here I am writing that values. In any semiconductor we know the electron concentration N is equals to Nc into e power minus of Ec minus Ev by kT and P equals to Nv into e power minus of Ef Sorry, it is a N material. So EC minus EF. So final equation I have written directly. Sorry. So EC minus EF by KT. Yeah, by KT. And here it is EF minus EV by KT. So once you said it is intrinsic semiconductor, okay, and you mentioned for intrinsic semiconductor, we know that N is equals to P and which is equals to Ni, intrinsic carrier concentration. That's why I am replacing this one by Ni. Similarly, P also I am replacing this one by Ni. And for intrinsic semiconductor, okay, Fermi energy level of intrinsic semiconductor is represented by the term EFI. Sometimes in some textbooks they mentioned it as EI. Okay, so I'm going to replacing this EF became EFI. I'm representing this one just by EFI. Here also replacing this by EFI. Okay, now see this NC into e power minus of EC minus EF by KT. EC minus EFI by KT. Let us take it as third equation. And here P means Ni into equals to NV into e power minus of EF became EFI minus EV by KT. Minus EV by KT. So these are the values of Ni from the knowledge of N and P. Just we apply a condition of intrinsic material on that. But equation 3 represents Ni and equation 4 also representing the Ni. Now I am going to equating both. Just I am equating both. Okay, by equating both, so this one equals to this one. Now I am going to simplifying this. Okay. See, now previous expression we have is Nc equals to Nc into e power minus of EC minus EFI by KT equals to NV into e power minus of EFI minus EV by KT. Now I am taking this one this side and bringing this one this side, this term this side. So NC by NV equals to, now NC by NV equals to e power minus of EFI minus EV by KT into e power this one. By taking this one this side, it became positive. So e power plus EC minus EFI by KT. Now I am simplifying this. Now it is e power KT in denominator. Here minus EFI minus into minus plus EV plus EC minus EFI. Now it is e power EC plus EV minus EFI minus 2 EFI by KT. So that is the equation for NC by NV. Now I am taking natural log on both sides. Now by taking natural log on both sides, ln of NC by NV equals to EC plus EV minus 2 EFI by KT. Just take KT this side. Now it is KT into ln of NC by NV equals to EC plus EV minus 2 EFI. So that is the equation. So take this EFI this side and these two this side. Now it became, so therefore 2 EFI equals to EC plus EV minus KT into ln of NC by NV. KT into ln of NC by NV. Now finally I am writing EFI is to this side. Take this to this side. Now it is EC plus EV by 2 minus KT by 2 into ln of NC by NV. That's it. That's it. That is the equation for EFI. So this is the first equation. Now I am going to simplifying this one once again. Let us take this is the equation A. Now I am going to substituting the values of NC and NV. Okay, if you check the values of NC and NV, here I am writing that values. NC is equals to 2 into 2 pi into Mn star into KT by H square whole power 3 by 2, and NV equals to 2 into 2 pi into MP star KT by H square whole power 3 by 2. Here we have NC by NV, just means this one by this one. By dividing these two, all are cancelled except Mn star, MP star. So from this you can write NC by NV equals to Mn star by MP star whole power 3 by 2. Okay, just take this one, substitute here. Now EFI became EC plus EV by 2, EC plus EV by 2 minus kt by 2 into ln of mn star by mp star whole power 3 by 2. Now just take this 3 by 2 this side. Now it became 3 by 4. So here EFI equals to EC plus EV by 2 minus 3 by 2 into 1 by 2, 3 by 4. 3 by 4 into KT into ln of mn star by mp star. Okay, this is the another equation. Let us take it as B. So based on the information, you can use any one of this. Now the important point is, if I take the energy band diagram of an intrinsic semiconductor, here is EC and here is EV. Let us, the midpoint of these two is EC plus EV by 2. That midpoint is EC plus EV by 2. This is the midpoint. So midpoint in this sense, you can write this is complete energy gap EG. Now it is half of that EG by 2, and this is also half of that EG by 2. Now intrinsic Fermi energy level is not exactly midpoint of that, it is less than something. So from this expression we are getting that, because EC plus EV by 2 minus something, this much amount, it is going to be less from center of the energy gap. Okay, so this is the expression for intrinsic Fermi energy level. Okay sir, so you can use either this one or this one. Now my question is, what is the condition required to make intrinsic Fermi energy level at midpoint of energy gap? Once again I am repeating, I want intrinsic Fermi energy level is exactly at midpoint of energy gap. For that, what is the condition? So from this equation you can say that that condition is NC becomes to NV. That means if NC equals to NV, then ln of 1 equals to 0. Now this whole thing became 0. Now EFI equals to EC plus EV by 2. Similarly here, if you are coming in terms of Mn and MP stars, now Mn star equals to MP star, then it became 1, ln of 1 equals to 0. Now this whole thing became 0, and EFI equals to EC plus EV by 2 minus 0 is EC plus EV by 2. Now at a condition of effective masses of electron and holes are equal, effective masses of electron and hole are equal, then intrinsic Fermi energy level is at midpoint of the energy gap. Okay, so now I am writing that one here. Note, at a condition of So it was asked previous GATE examination at a condition of effective mass of electron and hole are equal at a condition of effective mass of electron and hole are equal. So it means Mn star equals to Mp star at this condition. Well, the intrinsic Fermi energy level is intrinsic Fermi energy level is at midpoint of energy gap, at midpoint of energy gap. That is okay. At this condition, intrinsic Fermi energy level is at midpoint of energy gap. Okay. Now we are going to next topic. Relation between different energy levels. Relation between different energy levels. Now intrinsic is over. Now I am going to taking N type and P type semiconductors. Okay, in that N type and P type semiconductors, how different energy levels are related to each other. How different energy levels are related to each other. See here, we draw the energy band diagram of a N type semiconductor. Okay, this is EC, EV, EFI, and this is the Fermi energy level of N type semiconductor, EFN. Okay, so once again I am drawing this diagram here. So after completion of this topic, you should know every relation between every energy level. You should know what is EC minus EFN and what is EFN minus EFI. Okay, from the knowledge of that, you should represent in a position to represent the equation for EFI minus EV also from the knowledge of previous. Now and this one. So now I'm writing the equation. So this is EC and it is a conduction band. This is valency band, so it is EV. It is EFI. Next, this is going to be EFN, Fermi energy level of N type semiconductor. After completion of this topic, you should be in a position to represent a relation between these two and relation between these two. Based on the knowledge of these two relations, you can write the value for EFI and EV, or you can write EFN minus EV, whatever you want, you can write the value of it. Okay, So first of all, from this semiconductor I know only n value. N value of semiconductor I know. Okay, so n value is nc into e power minus of ec minus ef by kt. Okay, I will solve here. See this. This is the plot we drawn here. So I'm going to derive one by one after another. So another one is, this is EFN, because this is EC, EFN and EV. Now I am going to relating the expression for this. I want the expression, this one. I want EC minus EFN. That is my requirement. EC minus EFN. How much? How much it is? EC minus EFN. How much? And first of all, this is n type semiconductor. This is a n type semiconductor. Don't forget that. Okay. Now EC minus EFN. Okay, just keep this in your mind. Now we know n value. N is equals to NC into e power minus of EC minus EF by KT. Okay, now it is, now I am applying n type condition on this. That means your n type condition is, for n type semiconductor, we can write electron concentration is approximately amount of doping, Nd, donor impurity concentration, and Fermi energy level of n-type semiconductor is represented by the term EFN. EF became EFN because it is n-type semiconductor. Now I am taking these two values of n and EF, substituting in this main equation. N equals to NC into e power minus of EC minus EF by KT. After substitution, N became Nd. Amount of donor impurity you added, what you added, into equals to NC into e power minus of EC minus EF became EFN by KT. Okay, this is the equation for Nd. Now what I am doing is taking this Nd this side and this one this side. Just to take this one this side and this one this side. Now this is e power, this minus became positive, it is e power EC minus EFN by KT equals to NC by ND. Now I am taking natural log on both sides. By taking natural log on both sides, EC minus EFN by KT equals to ln of NC by ND. So, but we need EC minus EFN. Therefore, EC minus EFN equals to, take this KT this side, KT into ln of NC by ND. That's it. This is the expression finally. Simple, sir. EC minus EFN is KT into, KT common, sir, KT into ln of EC, conduction band, minimum energy level of conduction band, density of states in conduction band is NC, minus EFN. It represents EFN. N represents N-type semiconductor. In N-type semiconductor, amount of doping is ND. Over. Okay. So this is the first expression what we have. So this difference is, the difference is what we derive, EC minus EFN is KT into ln of NC by ND. NC by ND. That's it. Okay. Now I am going to comparing the Fermi energy level of N-type semiconductor. Fermi energy level of N-type semiconductor with intrinsic Fermi energy level. Let us take this is EFI. It is EFI, approximately midpoint. Now I want to relate these two. EFN and EFI. That means from this plot I want EFN minus EFI is how much. Okay, this is my next calculation. Okay, now I'm going to calculating that. More or less that equation also you get the same way. Here EFN minus EFI is equals to KT into ln of, here it is EFN, so that means ND. So ND, once again I am plotting that equation on the diagram. So this is our plot. Now this is EFN and here is EFI, center EFI. So this is EC EFN, Fermi energy level of N-type semiconductor, and it is EFI, intrinsic Fermi energy level. It is EV. Now they want this relation, this one minus this one. Okay, how much it is? EFN minus EFI is equals to how much? See, directly I am writing that equation. So this is EFN. So the expression for this one is KT into, from previous knowledge I am writing, ln of, so it is EFN minus EFI. EFN means here we have amount of doping ND. By adding amount of doping ND, Fermi energy level is shifted from here to here. Now it is ND, amount of doping ND by, so it is represents the intrinsic material. Now carrier concentration is Ni in intrinsic semiconductor. finally you get this expression. Okay, so once again we check this, we derive that one also. Now we are going to deriving that expression. First of all, the equation for electron concentration is, sir, you observed or not, more or less all equations I am going to be deriving either EFI or NI, and the relation between the energy band, different energy levels, okay, in a semiconductor of intrinsic N type and P type, all I am going to be deriving from the knowledge of N and P. Okay, that's why in last class I told you, please by heart N value and P value. If you know the N value and P value, deriving any equation, any relation within less than 1 minute you can get that equation. Okay, and substitute the values in that, within less than 2 minutes you can complete that problem. Now we know N value is NC into E power minus of EC minus EF by KT. This is the equation for N value. Sorry. Yeah, this is the equation for N value. Now EFN. So once it is EFN, it shows me this is N-type semiconductor. I want EFN minus EFI. From this, it is going to be intrinsic material. So here I am going to applying N-type semiconductor condition on that. Here I am going to applying intrinsic semiconductor condition on that. Okay, first from intrinsic semiconductor. Okay, let's first apply N-type semiconductor. From N-type semiconductor, we can write N value is approximately amount of doping ND, and Fermi energy level is EF became EFN because it is N-type semiconductor. Just take these two, substitute in this. Now by substitution you get ND equals to NC into E power minus of EC minus EFN by KT. This is the equation you get. Okay, let us, I am giving a number to that, let us take it as equation number 1. Next, I am taking now, it is a P-type intrinsic material. From intrinsic material, that means from intrinsic semiconductor, intrinsic semiconductor, from intrinsic semiconductor, N is nothing but a intrinsic carrier concentration Ni, and Fermi energy level EF is equals to EFI. Now take these values, substitute in this main equation. Now it became, so now it is N equals to Ni equals to NC into E power minus of EC minus EF became EFI by KT. So let us take this is equation number 2. Now I am going to equation number 1 divided by equation number 2. So I am writing that one here. Equation number 1 is this one, nd equals to nc into e power minus ec minus into minus plus efn by kt. Similarly, from the second equation is ni equals to nc into e power minus ec minus into minus plus efi minus ec plus efi by kt. So we are going to dividing these two equations. Now simplifying this, both nc gets cancelled. Now so nd by ni equals to e power minus ec plus efn. Taking this one here, it became plus, it became minus, plus ec minus efi by kt. Here these two gets cancelled, minus ec plus ec gets cancelled, and it became e power efn minus efi by kt. So just take natural log on both sides. By taking natural log on both sides, it became ln of nd by ni. It became efn minus efi by kt. So therefore efn minus efi by kt equals to ln of nd by ni. Now multiplying this with kt, therefore efn minus efi equals to kt into ln of nd by ni. Okay, just to verify the previous case, we've written this equation already from the knowledge of previous calculations. We've written this equation in this energy band diagram. efn minus efi is kt into ln of nd by ni. See this here, kt into ln of nd by ni, kt into ln of nd by ni. Okay, so that is the equation for different energy levels present in a n-type semiconductor and the relation between that energy levels. This is for n-type semiconductor. So whatever the analysis we done on n-type semiconductor, similar type of analysis we do on p-type semiconductor. Now these are the equations here. Now I am taking p-type semiconductor. So from the knowledge of previous, directly I am writing that p-type. In p-type we have, it is EC and EV. This is a Fermi energy level of p-type, EFP, and intrinsic Fermi energy level is EFI. Okay, now first you need to relate these two, after that relate these two. EFI minus EFP is just go this side, opposite direction. Previously we came from top to bottom for n type. For p type, just go to bottom to top. Now EFI minus EFP equals to KT into ln of EFP means NA by EFI means NI, and EV minus EFP equals to KT into ln of, sorry, EFP minus EV equals to KT into ln of, for EV we have NV, density of states in valency band, by EFP means it is p type, so it is Na. Okay, now we go and derive those equations. See, now I am taking p type semiconductor first. Okay, and energy band diagram of p type semiconductor is like this. So this is the complete energy band diagram. This is EFI. Now EFP. This is conduction band, valency band, minimum energy level of conduction band EC, maximum energy level of valency band EV, intrinsic Fermi energy level EFI. This is Fermi energy level of p-type semiconductor EFP. Now I am going to rating one after another from, okay, and basically I know the concentration of holes in a p-type in a semiconductor, whatever it is, it may be n-type, p-type, intrinsic, whatever it is. Hole concentration P is represented as density of states in valency band NV into e power minus of EF minus EV by KT. This is the equation for hole concentration in a semiconductor. Okay, now first, which expressions you want to, which equation, which energy levels you need to compare or you need to derive. Now first I am going to relating these two. So first case I want EFI minus EFP. So from the previous knowledge, directly I am writing that value. It is you get it is KT into ln of this side. It is EFP, that means it is Na, by it is EFI, that means it is Ni. You get this equation. Now we go on derive this. Okay, first EFI. So EFI means it is an intrinsic semiconductor. Now first, from intrinsic semiconductor, we know that hole concentration P is equals to Ni, and Fermi energy level EF is equals to EFI, because it is intrinsic semiconductor. Now I am substituting these two in this main equation. Okay, now it became Ni equals to NV into e power minus of EFI minus EV by KT. Let us take it as equation number 1. Now next I am taking EFP. EFP is the Fermi energy level of p-type semiconductor. Okay, now you need to take p-type semiconductor condition. So from p-type semiconductor, we know hole concentration is equals to approximately amount of doping Na, and Fermi energy level EF equals to Fermi energy level of p-type semiconductor EFP. Fermi energy level of p-type semiconductor EFP. Now I am taking these two values, substituting in this main equation. So it is, therefore P became Na, Na equals to NV into E power minus of EFP minus EV by KT. Let us take it as equation number 2. We need EFI minus EFP. Now I am going to taking later 2 by 1. Equation number 2 by equation number 1. It is, equation 2 is Na equals to this much. Now Na equals to NV into E power minus of, so I am writing directly, minus EFP minus into minus plus EV by 2, and first equation is this one, Ni equals to NV into E power minus of, sorry, so minus EFI minus EFI minus into minus plus EV by KT. So we need to take the division of this one by this, equation 1 2 by equation 1. Now here these two gets cancelled. Now Na by Ni here, therefore Na by Ni equals to E power minus EFP plus EV by KT into E power minus EFI, sorry, it became minus, it became positive when we are bringing this denominator to numerator. It is EFI, it is minus EV by KT. Now I am simplifying. This is a ND by Ni equals to E power minus EFP plus EV plus EFP, sorry, EFI minus EV by KT. So here this EV and this EV gets cancelled. Therefore ND by Ni equals to E power EFI minus EFP by KT. Now I'm taking natural log on both sides. By taking natural log on both sides and bringing KT this side, so it became EFI minus EFP is equals to KT into ln of n. Sorry sir, this is NA sir, we've written by mistake it as ND. It is NA because most of the cases we are taking n type, that's why by mistake I've written. So it is NA by NI. That's it. So this is the expression for Fermi energy level of intrinsic semiconductor and Fermi energy level of p-type semiconductor. Okay, so one expression is over. See this, the same thing we've written here also, KT into ln of NA by NI. These two are related so far. Now we are going to relate these two, EFP and EFI. Knowledge of these two are sufficient to relate the remaining things. Okay, to relate the remaining things, knowledge of these two are sufficient. So I'm going to the next screen. So for this you get expression of so just wait, there is a issue with the screen. Yeah, now see this. Now this is the energy band diagram for p-type semiconductor. This is the intrinsic Fermi energy level, and this is the Fermi energy level of p-type semiconductor. EC, EV, this is EFP, and it is EFI. So already we related the EFI and EFP is over just before we derived this equation. Now I am going to deriving EFP minus EV. Second case, I want EFP minus EV. I want this. And we know one expression just before previously what I've written, P is equals to NV into E power minus of EF minus EV by KT. We know this expression. You know we need EFP, so that means it is a p-type semiconductor. So from p-type semiconductor, P is approximately equals to amount of doping Na, and Fermi energy level of p-type semiconductor can be written as EFP. Just take these two values, substitute in this equation. then P became Na equals to Nv into e power minus of EFP, because it is p-type semiconductor, minus EV by KT. Now I'm taking this one this side and this part, exponential part, this side. So we can write it as now e power EFP minus EV by KT equals to NV by NA. NV by NA. Just take natural log on both sides. Taking natural log on both sides, then it became EFP minus EV equals to KT into ln of NV by NA. So this is the expression for EFP minus EV. Relation between Fermi energy level of p-type semiconductor with maximum energy level of valency band. Okay. So far we derived the equations for intrinsic carrier concentration, intrinsic Fermi energy level, and after that we took the n-type semiconductor. In n-type semiconductor we done two derivations. First one is we relate the minimum energy level of conduction band EC and Fermi energy level of n-type semiconductor EFN, and after that we derive an equation between Fermi energy level of n-type with Fermi energy level of intrinsic semiconductor, that means EFN minus EFI. And after that we took the p-type semiconductor, and here also we done two calculations. The first one is we relate the intrinsic Fermi energy level and p-type semiconductor Fermi energy level, that is EFI minus EFP, and next one is Fermi energy level of p-type semiconductor with maximum energy level of valency band EV, EFP minus EV. Okay, here now I followed one order. Okay, now whatever the equations so far we derived, I will write all the energy equations at one point. Okay, let us take, this is the energy band diagram. So I'm going to be merging taking the both energy band diagrams on one point, on one diagram. Let us this is the EC and it is EV, and this is the intrinsic Fermi energy level EFI. If it is n-type, this is the Fermi energy level of intrinsic semiconductor, n-type semiconductor, and if it is p-type, this is the Fermi energy level of p-type semiconductor. Okay, so conduction band, just a minute. Yeah, it is conduction band, it is valency band, it is EV, EFI, EC, and EFN. This is the Fermi energy level of p-type semiconductor EFP. Sir, for your easy understanding purpose, I am placing all the energies on a single diagram. Okay, for n-type and p-type. Okay, now first I am going to writing the equation for these two, relating these two. Let us equation number one. Now first equation is, just I am following this order, sir, this order. EC minus EFN. EC minus EFN equals to KT into ln of NC by ND, because it is p-type semiconductor, n-type semiconductor. NC by ND. That's it. That is the equation 1. Next, I am going to relating these two. Let us take this in. I am representing this one by equation number 2. So equation number 2 is EFN minus EFI, which is KT into ln of EFN. Simple, sir. It is EC, so you can use NC. Here amount of doping is ND. Here it is intrinsic Ni. Here amount of doping is Na in p-type. Here it is NV, density of states. So EFN minus EFI. So ND by Ni. Simple. Ni. That's it. Third one. Now I am relating these two. So this is represented by the third equation. So that is EFI minus EFP. EFI minus EFP equals to KT into ln of. See, from EC to EFI you forwarded in this side, this direction, up to here. Now from EV to EFI just you follow this direction. Now the equation is, but energies are the same side, same direction. So EFI minus EFP is KT into ln of Na by Ni. Na by Ni. Next one is I am going to relating these two. Let us take it as fourth equation. So now I am representing that one by fourth equation. That is EFP minus EV equals to KT into ln of KT into ln of EFP minus EV, NV by Na by Na. So these are the different energy relations for n-type and p-type. And here I am adding equation for intrinsic Fermi energy level. EFI equals to, already we derived this one, sir, EC plus EV by 2 minus 3 by 4 into KT into ln of Mn star by Mp star, effective mass of electron by effective mass of hole. These are the different energy level, energy equations. Okay, so please don't forget this. The way what we followed to write the equations is very easy. Okay, so for your better understanding purpose only, I merge the energy band diagrams of p-type and n-type on a single band diagram. Okay, so these are the expressions. See, these are the expressions for n-type, and this is for p-type. Okay, now thanks for your spending your valuable time with me. Okay, and during subscription don't forget to use my code VROW10. Okay, and please click this bell button to get the notifications about my classes, and join our telegram group for latest updates. Okay, so what are the next coming classes, what is the time for the class, and which topic the class is going on, which subject. Okay, to get that type of updates, join our telegram group. Okay, and I'm inviting you, please give the comments on my class. That comments are helpful to me to strengthen myself. Okay, and in future, okay, by taking those comments, okay, I will prepare the info, I will give a more informative information to you. Okay, thank you, thank you very much, and thank you all. And once again, I'm telling one important point to you. In this pandemic situation, please control your restriction, your movement at outside. Please restrict to at your home only. Okay, if you have any emergency work, then only come outside, otherwise please be at your home. And even though whatever happening in the world, our learning process should be continue, it doesn't stop. Okay, our learning process should continue. So please don't break your studies by joining this Unacademy, India's largest learning platform. Continue your learning process. Already in previous class, I explained the benefits provided by this Unacademy in all the aspects, and the whatever the fee you are paying at outside, more or less by adding addition by transportation fee. I am not talking about the fee what you are paying at outside. Just by adding little bit amount to your transportation fee, okay, you can get all the classes at your home only, at your home itself. Okay, by staying at your home safely, you can get all the classes. Okay, please subscribe. Don't forget to subscribe during subscription using my code VROW10. By using this code, you get 10% discount. Okay, thank you very much. Thanks for spending your valuable time with me. Thank you very much.